include this much in this chapter. Okay, now let's explore the different types of new metals. If I have a field, what are the possible? Is it possible to have such a field? Configuration, is it possible? It's an electrostatic field. Strictly, it's a purely electrostatic field. What is the basic idea? Work done by electrostatic, like a work done in a closed path. Work done by conservative field in a closed path must be 0. I'm going to take help of that condition. So I'll bring a closed path. So what is the closed path? Okay, let me start like this. Then I'll point 1, 2, 3, 4. Work done in a closed path must be 0. Net work done in a closed path 1, 2, 3, 4 should be 0. It's a conservative field. I'm saying it's electrostatic field, first of all. It's an electrostatic field. So is it possible? I'm asking. So first, what is work done in the path 1, 2? Where the field strength is more? At 1 or at path 1, 2 or 3, 4? Definitely at 1, 2, it's more. No spacing between the lines is here less. Here spacing between lines is more. So the field strength at point A. So EA will be greater than EB. Then what about the work done in the path 2, 3, and 4, 1 will be 0 because E bar will be directed perpendicular to the you know many concepts of work done, take help of that. So how E bar along for path 2, 3 E bar will be perpendicular. So what is work done along the path? Work done along the path 1, 2, select it 2, 3 and 4, 1 is 0. Any reason for that? E bar perpendicular to DL bar. No, work done along the path 1, 2 should be equal to, shall we go for like a Q E bar, like a force like a Q into EA bar dot DL bar. Work done along the path 3, 4 equal to Q EB bar dot DL bar. But we know it's a conservative field. What is the net work done by conservative field in a closed path? Why it should be 0? Because it's a conservative field. From this description, what I can say that W12 not equal to W34. So what happened? Work in closed path has in fact become non-zero. So therefore the field is a not possible. It's not a conservative, but electrostatic field must be conservative. So therefore such a field is not possible. Getting the idea? if they give any field, work done in closed path must be zero. If it is not zero, then it's not electrostatic field. Any reason for that? Because all electrostatic field must be conservative, produced by static charges. I'm making some conditions clear. Electrostatic field produced by a static charges must be a conservative field. I'm saying this field is produced by a static charges. So then what happened? The work done closed path must be zero, but I'm getting non-zero. So how do you can say non-zero? You see that I'll move from 1 to 2. What is the length of the path? Let it be say some L. There's no problem. Then what is the biggest problem here is like the field strength at A is greater than B. So when I add up these two, will not become zero. In fact, it will be non-zero. So net work done in closed path will be non-zero. So therefore, such a field is not possible. So what is the conclusion I can make it? This is for conservative field. This is the only method available for it. According to the data, it is non-zero. Net work done is for path 1, 2, 3. So therefore, such a field is practically not possible. Okay, fine. Let me give one more field of this kind. Concentric circles, I'll bring it. Is it possible such a field? One more will have. No. Now look at there's a field. So again, you do one thing. You take closed path. What is the closed path? Just very simple. The closed path, can it be like this? Calculate the work done. Will be non-zero. Similarly here, I'm asking you to take a closed path here. Will be non-zero. Net work in closed path will be non-zero. So therefore, definitely these are not possible. There's only alternative available for us. So net work done. So we'll give the points 1, 2. So not possible. Such a field not possible. These are very popular questions. where they'll ask you. So you should use only, there's an alternative method available for us.